right now. So this box that's up on the left side of me is actually a material science experiment that came on our space shuttle. We brought it up to space with us, and we were sticking it on a platform outside of the European Space Agency's element. It actually had a power cable that was going to provide power while they performed material science experiments on it. It's attached to me by a thing called a ball stack. It's kind of like one of those snake lights that you see at the hardware store that you can wrap around something and it will stay in position. I can control the tightness of that thing, so I can tighten it down so that box will stay where I put it. It's got a fancy attachment mechanism so that I can attach things like experiments and stuff to it and travel around with them. This tether is what this is. It's a tether reel. It's about 85 foot of elastic line that spools up inside of there, and so if I let go, I can never get more than 85 feet or so away from the space station, so that I wouldn't have to fly back to the space station using my rescue pack. You can't see very much of it, but this thing that's hanging off the back of me here, the lower portion of that is that rescue pack. It's got some compressed nitrogen, and it's also got a battery pack in there, and I can use it with a hand controller that pops out of one side of it to fly myself back to the space station if I was to come loose. But like I said, I don't want to take advantage of this thing, but it would never let me get 85 feet, further than 85 feet away from the space station. So I've got a couple of safety mechanisms to keep me from getting too far apart. Probably the most important of which is my right hand here that's holding me on to the space station. So I always felt more comfortable holding on than I did relying on one of these tethers to make that happen. Thank you. See, this thing on the front of me is called a mini workstation. It's got a capability to kind of fold out in front of me, and it's got a series of tethers. As you can imagine, and you probably heard about the poor woman who had her tool bag float away. It was just a failure of that process for her to get a tether onto something and keep track of it. We have to remain tethered to everything, just like we have to remain tethered to the space station so that we don't float away. Of course, you can see my helmet lights up here. I got a couple of different options there for cranking up, whether it's a wide beam or a narrow beam. This is also a piece of my equipment. It's a tool bag. This is exactly like the one that floated away on that previous flight with that one astronaut. This actually might be the same bag. There were only 4 of them on the space station. I don't know which one actually floated away, but it may be the same bag that you can see I had tethered here, but that got away from the other astronaut. And see, I'm not sure if there's much else. This is a trash bag that I stuff junk in that is untethered and I need to keep track of. This is my spacesuit. Go ahead.
What is your range of motion? Did you actually use your arm?
The center portion of the spacesuit is actually a rigid structure, so you can pretty much just move your arms. You can move your legs a little bit, but spacewalking is a misnomer. It's actually space crawling. Pretty much everything that you do is based on moving around on your hands like a kid crawling around on the floor, like the monkey bars, basically. So, on the helmet, we do have a couple of visors. We have everything from the full blast shield, which is a metal plate that no sunlight can get through, to actually just like sunglasses that we can fold down on that as well. We have wrist mirrors so that you can hold your hand someplace, and actually the most useful place, it's hard to see here, but there's a sequence. This is one digit of it, this is another digit of it. There's actually a valve that we move from different positions to provide the pressurization in our suit, and to be able to read the labeling on our suit. By the time you get into space, you just know where it's supposed to go, but you can use those wrist mirrors here, and I have one buried down in here someplace so I can read things by holding my hand out and just looking at the mirror. Any other questions about the suit?
Can you turn your head left to right, or do you move the rigid body with the torso?
I can turn my head left to right inside of the suit, but the head is rigid attached to the suit. So I have that flexibility to get a little bit more field of view, and the helmet is actually such a tight fit that if I was to turn my head all the way to the left or to the right, I'm in contact with the back of the helmet, so it's kind of uncomfortable to do that for very long. So you end up using your eyes a lot more than actually turning your head, just using as much of the peripheral vision as you can. There's also a backpack that is actually probably the most hidden thing and probably the most important thing on the suit, but it's as tall as I am and comes down right to about here, and then that rescue pack is down below us. That has compressed oxygen in it, a couple of different tanks. It's got a big battery in it. It's got a system for pumping around water. There's actually a sublimator that's on the front of this. It's actually on the top back of the suit. A sublimator that actually bleeds off some water, flashes it into a solid little ice pack, and then we use that to circulate water around the backside of it to provide cooling for the crew members that are inside the suit. So one of the other adjustments that you have to make, and you can kind of see a half moon of numbers here, is what your temperature is. Like I said, you don't want to sweat when you're on orbit. It's a bad day, because as soon as you're in the cold after that, you will rapidly get too cold. Go ahead.
How do you get from the airlock to where you're working?
Pretty much just like on the monkey bars, hand over hand to get where you're going. Go ahead. Right. So what we do is the night before, that picture that I showed of Mike and myself getting ready to go out for our spacewalk, that was the night before. So we put our 100% oxygen masks on, we put on all of our stuff, and we went into the airlock the night before, spent the night in there at a decreased pressure to help bleed off some of that oxygen, that nitrogen that was in our bloodstreams. And then the following day, we went out for the spacewalk. The day of the spacewalk, we get up, and probably 3 hours later or so, we're out the door doing our spacewalk. But during that 3 hours, we do get 30 minutes of what they call a hygiene break to get some food and visit the restroom before heading outside. Okay.
How do you avoid the mask fogging up on the inside?
There's a couple of ways that's avoided. One is with an anti-fog coating that's on the inside of the mask, but also the flow into the suit actually comes out at the top of your helmet and blows down over the front of your suit. So all the air that's introduced into the suit actually comes down and rushes across that visor area to keep any fogging from occurring. It's like a window defroster in a car, and then the actual return ducts are in your extremities, or in your hands or in your feet, to guarantee that you actually maintain some circulation.